All right, so let's look at the first one. So this one should have been extremely easy. They gave you the figure, they labeled the curves, and then they told you they wanted it to be perpendicular to the x-axis and they wanted it to be square. So I'm going to start you off with your volume should have been, oh Lord, your volume should have been the integral of the area of the cross-section. So can you start off with that? You should be able to give me the number here, the value here, and whether it's a dx or dy. Can you start with just that piece? A lot of you did have that written, and then maybe got something wrong as you went through that. So if you had it written, what's the shape that we're doing? Square. So that's the easy part. We know that it should be s squared dx or dy. Dx. If it's an x, look at your x's. Your x's go from 1 until 4. If it's a dx, you look at your x's to figure out where it goes from to where. Then your s, you figure that out by coming over here, drawing your segment. So this creates the square. If you want to draw the square, there it is. You don't need the whole square. How do we label this? Top and bottom. So your answer becomes the integral from 1 to 4 of the top function, which is x squared minus, or over 10, minus the bottom function, which happens to be negative x squared over 10, which means I'm going to turn that to a plus, squared dx. This is a calculator problem. All I needed to see was this piece, and then you use your calculator for everything else. Some of you sat there and found the antiderivative, did all this work. I don't want to see any of it if it's a calculator problem. I want to see the integral. That gets you most of your credit. And then everything else goes in the calculator. Do not waste time. That's the minimal amount of work I need to see. That's it. Okay? All right. So that was number 1. Are there any questions on that guy? So notice the process. Area of a cross-section, is it a dx, is it a dy? Figure out your limits, figure out your area formula, and then draw your top bottom. And that's going to be the same thing I do for each of them. Number 2, most of you, same concept. So start off, if you made a mistake, some of you may have already found your mistake. Start off, please, by writing the volume is the area, integral of the area. I want the area formula here. I want dx or dy. And I want numbers here and here. Do that part first. Just start with that, and then I'll show you where most of you made your mistake and why I didn't give partial credit for this guy. Let's do the easy question, dx or dy? Dx. So if it's a dx, then you look at your x's. Where do my x's go? From 0 until 8. Did you hear what I said? If it's a dx, then you look at your x's. That's when you look at the domain of the picture. The picture goes from 0 to 8 in terms of a domain. That part should be set up. I know that the cross sections are semicircles. What's the area of a semicircle? 1/2 pi r squared. So that much I know. So then from here, the only thing I have to figure out is the actual radius. So then it was the idea of understanding that if the cross-section here is a semicircle, it looks like this. You guys see it? It's hard to see. So top and bottom, which is what most of you put in for R. Is that the radius? No. What is the radius? 1/2 of the top minus bottom. And remember I did this problem, and remember we talked about the halves, and remember I said make sure you control and understand where the halves come from. So 0 to 8, 1/2 pi, and then r, this r is 1/2 of the top minus bottom. The top function happens to be the x plus 2y equals 8. This is supposed to be a dx problem. If it's a dx, which one do I solve for, x or y? Y. So I get 8 minus x over 2. So now I just picked up another 2. So 1/2 of top minus bottom, which I don't need, dx. I don't need the minus 0, but there's everything. Do you notice I haven't changed the way I've done the problem? Area of a cross section, dx or dy, top, bottom. All those pieces are there. I'm doing the same thing each time. Are there any questions? Yep. Where do I have my squared? Yes. Thank you. Yes, I need the square. R squared. Anything else? Okay. All right. So 2. Let's look at 3. 3 was pretty quick. You could have done the problem 2 different ways, but only the dx question. This answer choice that worked was the dx answer choice. The dy answer choice wasn't here, but you could actually do the problem as a dy also. It could be done both ways. Okay? Meaning you should be doing a top-bottom for this one. You can do a right-left. It just doesn't show up as one of the choices. Number 4. So at this point, took away the calculator. Area of the region. So we're back to area. Area is a very basic concept of top and bottom. You found your intercepts, hopefully, correctly. So this process would have been to find your x-intercepts. Second, sign chart, or kind of like a sign chart. And then 3, integral from a to b of top minus bottom dx. In this case, there was only 2 x-intercepts, which means it was definitely a top-bottom problem. Okay? So I'm not going to go through that one. I'm hoping you can see where you might have made a mistake. Can someone give me the intercepts, though? 0 and 3. So 0 to 3, so you needed to check a point. I would have checked f of 1, and I would have checked g of 1. Okay? So A, B, top and bottom would depend on which one gives us the top value and which one gives us the bottom value. Are we good on that guy? Okay? All right. So first thing I would have done, draw. Draw the figure. If you don't have it drawn, then please draw. A lot of you did have it. You looked at it and then never finished the problem. So let's see. Graph of x squared, x equal to 2. That'd be 2 comma 4. X equal to 2 and x-axis. So that's the area. I'm revolving about the y-axis. So you should ask yourself, is it a washer or is it a solid? Is it a dx or is it a dy? Okay? So, is it a washer or is it a solid? Washer. You see all that space in between? If you don't trust it and you don't understand why it's a washer, I will show you one more time why it's 100% a washer. Symmetric image. On the other side, this piece is also shaded. You can see that there's a gap, and then this would be the outer circle, and then this here would be the inner circle, and then that would all be shaded in. That's why it's a washer. Okay? So that visually shows you why it's 100% a washer. How do we tell just from a two-dimensional, one-sided figure that it's a washer? Because there's a gap. There's a gap here. Okay? So we know it's a washer. I'm going from this part of the figure, going towards this line over here, which is the axis of rotation. Is it going to be a dx or a dy? dy. You need to know those two pieces first. Okay? Now that I know that, I'm going to write down my washer formula. My washer formula, which I know it's a dy, what are the y values that I use? The lowest the picture goes is 0. The highest the graph goes, 4. So that tells me my values. I already know it's a dy, and if it's a washer, I should be setting up pi big R squared minus little r squared. That's where I would start. So that's my setup. Now that I have it set up, I just got to figure out my big R and my little r. So this will be repetitive to the last page where I made you do a bunch of these. I'm going to draw my big R. So from the axis of rotation, I go towards the furthest shaded part. Once I do that, because I'm going side to side, what do I label them? Right and left. So this side is the right side, this side is the left side. Should I ever do any of these without a graph? No. How do you know where the right is and where the left is? How do you know which one is longer or shorter? You don't know that unless you have a graph. There's my right and left, and then my other one I'll do in, let's do pink. So axis of rotation, closer part. That's little r, and that's little l. Now I have everything that I need. In this case, though, my lefts were just 0, so I'm not going to actually end up having to use them. From 0 to 4, pi. So big R would be this line, which is x equal to 2 minus 0. I'll put it here just so you see them. Minus little r, which is here, and this is this curve, which I don't think we have written. This is x equals plus or minus the square root of y. Are these y values the positive y values or negative y values? Positive. Oh no, sorry, wrong way. Are these the x values that are positive or the x values that are negative? Positive. You don't get to just write it. You gotta guess. You actually ask yourself that question. All right. So there are my positive y's. So here we go. Square root of y minus 0. That's the equation. Simplify it. Then you would find your antiderivative f of b minus f of a. So I'm skipping that part. I think the setup, once you get here, you should be able to simplify from there. Okay? Questions on this one, please? Okay. So this is how many people should have come for help when you guys were struggling, because I'm pretty sure there's no way to go completely not be able to do everything if you did all the work I gave you and did it correctly. Okay, Samson? See how this is x equals this equation? The x's for this equation, the only way that equation will work is if I use the positive square root, not the negative square root. This side happens to be the negative square root. That's the reason why. Okay? The other way I know, the only way that that would satisfy the point positive 2 comma 4 is if the root was the positive root. That's the other way I know it. Okay? All right. 5. All right, 6. So, you would think, I thought you would figure out, why would I have left all this space right here? What do you think that might be helpful for? A little sketch. Be a nice little place. Why did I think that you would figure that out? Because every problem I did that I gave you the keys for, remember I had this in the notes, and then I did the problems for you and I gave you the answer key? You remember that? And what did I have in that space for every single one of them? A sketch. I gave you the exact same problem lineup. I gave you equations, gave you a sketch, and then just asked you a bunch of volumes. So the shaded area you could have done 2 different ways. Because I gave you the area here, you could have done it as a dx or a dy. It actually didn't matter which way you did it. Hopefully because we just did some area that you would be able to do that problem. So for that one, to be honest, the easier of the 2, so what I did was I just kept redrawing this thing. The easier of the 2 was top bottom, because the bottom's 0, it makes it a little bit easier. So top bottom would be the easier, top, bottom, and my x's go from -4 to -2. Another question that I think some of you don't understand, which one's the smaller number, -4 or -2? -4. That's the bottom number. It doesn't go on top. The domain goes from -4 to -2, so the domain is how we figure out minimum, maximum of our integral. All right, are we good on shaded area? The only one that was shaded area? Yep. follow through. You made a mistake somewhere else and I didn't keep taking points off. You made the same mistake over, or you made a mistake and it followed through. Volume if rotated around the x-axis. So if I'm rotating, that's the other thing I realized. If you're rotating, sometimes I do skip a step, and I might not write the area of the cross-section, but that is a cross-section. If I rotate, what shape is your cross-section always? A circle. But you should be asking yourself, solid or washer, and you should be asking yourself dx or dy every single time. So if here's my picture, my little shape, and I'm going to rotate about here, solid or washer, solid, dx or dy, dx. So that's the setup. Now that I know the setup, here's my general formula. It's from A to B. If it's a dx, we already used our x's in this problem before. I'm using the same x's again, pi r squared dx, and then I just got to figure out what my r is. My r would be, come over here, top, bottom. Bottom happens to be 0, so I don't really have to worry about that. The top is the same as the function that's already up there. Okay? So I haven't changed the way I'm doing my problems. So that's B. Once I do that, for each of these, you should be able to do and fix each of them, and I will talk about this one in a second. So here's my picture. Perpendicular to the x-axis tells me it's a top-bottom problem, whose height is 4 times the base. Some of you had base is equal to 4 times the height. That's something weird. Can you guys try and fix this one if you did get that one wrong on your own? Try to fix that, and we'll talk about letter E in a moment. So volume is equal to the integral from -4 to -2. We already know that because it's a dx problem of a rectangle, base times height times dx, but base times height. My height is 4b, so I end up with 4b squared dx, and b is the top minus bottom again. So that b, that base, is this again. So if I just put that top minus bottom into my b right here, then I got c. Part E was the first one where you had to do a dy. You could have done a dy in the shaded area, but you weren't forced to do it. You are forced to do letter E as a dy. And most of you could not solve that equation properly. So here's the equation. Y is equal to negative x plus 2 squared plus 4. First of all, you're not taking an inverse. So if you switched your x and y, that was incorrect. I am writing the same equation in terms of y, not changing it. When you do an inverse, you're physically changing the function. You're making it a totally different graph. So first thing I would do, subtract my 4, divide by a -1, plus or minus the square root, and then the -2 comes over. So this is where I'm stuck, and this one was a little bit harder because you did have to think about which one to use. So I just pick a point. I actually know which one, but pick a point. Pick that point. Pick this point. Okay? That you don't want to use because it's the vertex. Those are the points that are going to work. It's that side of the parabola. You notice I stopped it at the vertex? It should make sense I'm using this side of the parabola. And if I'm using that side of the parabola, pick a point, -4, 0. -4 would go here, 0 would go here, and you'd have to figure out which one. If you got that wrong, I think in the end I took off at max 2 points. I didn't keep taking them off. Hopefully, I think I took it off once on the front, once on the back, but 1 point only. Okay? But that did matter. Okay, it did matter which one was going to be the answer. All right? So, if I want the x to be -4, you have to use the minus sign. It doesn't work with the plus. The other way you know, this is a parabola. This is the left side of the parabola. It tends to be the minus side. The right side being the positive side. That's the other way you could have kind of guessed your way through it. Okay? So that's why that is the equation, which is the same as if you wrote it this way. Some people decide to write -2, and yes, it should be minus 4 minus y. I think in my key I left it that way. That changes, makes it a little bit harder for letter E, rotating about the line x equal to -2, which is right here. Washer or solid? Solid. Dx or dy? From the shape, go towards the axis of rotation. Dx or dy? Dy. Let's see. Okay? So you should be able to do the problem. Right is this side. I use those words to make it helpful. And this is the left side. So the right side is not the function. What's the right side? It's -2, not the function. The left side is the function. I think it was the -2 minus square root of -y plus 4. Okay. The order does matter. And I know some of you may argue, oh, well, if it's in the end, my answer still worked out. If you don't understand why it works out, then I don't give you the credit. If you know the math behind why things work, I would give you the credit, but most of you make a mistake. And then you go, oh, but it still worked out. Very different than understanding why it does still work out. The square does make it so that sometimes the order may not matter as much, but I still would like the order proper, please. So you should be able to do this, guy. If you can do those, you should be okay to do the backside. You should be okay to do the backside, including this picture. So I'll draw the pictures for each of them, which actually make them pretty easy. So there's the sketch. I'm rotating around the line x equal to -7, which is all the way over here somewhere. That's where I'm rotating. Washer or solid? Washer, dx or dy? Dy. Shape, 2 axes of rotation, right? So that's definitely a dy. So you know it's a washer, you know it's a dy. So making sure you understand that that means if it's a dy, the lowest the picture went was 0. Highest the picture went was 4 pi. If it's a washer, r squared minus r squared. Dy. Axis of rotation, furthest part of the curve. Which side is the right side? This side. Which side is the left side? The one that's going to be on the left. I'm using those words to help you. I'm not trying to be tricky. I'm not saying the math right side. No, I really mean right side, left side. From the axis of rotation to the closer part of the curve, right side, left side. Most of you got it wrong because you never sketched it, and then you didn't know right from left. Can't help you with that. Okay? Yeah, I really do mean right. I don't mean, oh, now that it's on the other side of the axis, now you're going to change what I told you are the rules. I make rules so that you know I can change the circumstance, and I purposely gave you one in that quadrant because I wanted to know, do you still know that we're doing right and left, top and bottom? Nothing's changed. I give you one down in the left bottom quadrant, quadrant 3. Same rules apply, top, bottom, right, left. None of the rules change, or I wouldn't give it as a rule. That should get you through everything. You're welcome to stay and try to finish up any questions that you might